Okay, this should be a real quick one. We just have one concept and a couple different problems we're going to practice. We're going to, come together and go through a few together because there are some different things we have to look at here with talking about triangle proportionality. So you have seen this picture before when talking about triangle similarity. And if you recall, when we have parallel lines like this, guaranteed these two triangles will be similar by angle. Now, first off, you have to be able to see the two triangles. Do we see the two triangles? We have VWX nestled inside of VYZ. So those are the two triangles we're talking about here. The little baby one inside, and then the whole big triangle. That's what we're talking about in these two questions, or in these questions. So make sure you have this copied down. The triangle proportionality theorem. If a segment is drawn within a triangle that is parallel to one of the sides of the triangle, so these lines are parallel right here, then what ends up happening is the segment divides the sides proportionally. So more importantly, here's what this means. We have this proportion here. In this figure, and copy this down, VW, I'm going to write here, we have VW, which is this piece right here, over WY, which is the little piece on the same side, has the same proportions as VX, which is over here, over XZ. So notice how these match up, right? I did red over purple, red over purple. We have to be very careful when we write proportions so that they are that way. Now, again, when we talked about this, we have a lot of options with our proportions. This is true. VW over WY equals VX over XZ. However, we could also write this proportion as reds in one fraction and purples in one fraction. When we write our proportions, we have lots of options. They just have to correspond in some way. So VW corresponds with VX because they're both red. So I could write a proportion as VW over VX. That's again red over red. This also equals purple over purple, WY over XZ. I could write this and still be correct, and I would still get the same answer. An example that I can't do is VW and XZ. Those don't correspond in any way. VW is a red and on the left side. XZ is a purple and on the right side. None of those match, right? So I could not put VW and XZ in a fraction together. So there is an incorrect thing. You can't do that. They have to correspond in some way. They have to share something. Again, the VWs we said were the reds. And more importantly, they're the tops, right? So we have to be very careful when writing these proportions that things in a fraction have to correspond to each other. Now, we're going to keep this in mind, but again, this is going to change a little bit, as well as that sometimes the letters are going to change. We're not always dealing with V, W, Y, X, Z. It's going to be sometimes different letters, so we have to think more about the positions than the letters when we're doing this. Okay, so let's try this first example. If you could copy the picture and then label this information, we are going to find Vx. Okay, so VW equals 14 from here to here. WY is 6. XZ is 8. And since we want to find Vx, I'm going to call this little x, right, like our variable. So I don't mean this x, I mean like our variable. So again, when we set up our proportion here, we just have to write our two fractions so that in one fraction things correspond to each other, in another fraction things correspond to each other. So what we had was, again, given to us was that top over bottom equals top over bottom. This is a true statement. So I want you to try it yourself first. It's okay if you don't get it yet. We're going to try some more examples. But write your two fractions, doing top number over bottom number in one fraction, and then from the other side, top number over the bottom number. Go ahead and try it. Okay, so we have, if we're doing top over bottom, we have 14 on top, over the bottom is 6, and we have top number on the other side, over the bottom number is 8. We have lots of options. I could write this differently. I could go bottom over top. I could go 6 over 14 equals 8 over x. We even have other options from there. But as long as when you cross multiply, you get the same thing as everybody else who did it correctly, then you're also correct. So take a moment and cross multiply this, because a couple of you guys are still doing this wrong. The whole point is we don't have fractions anymore. We have 6 times x goes on one side. We have 14 times 8 goes on the other side. Go ahead and give it a shot. Okay, so 6 times x is just 6x. 14 times 8 is, I need this myself, 112. So once more, that is the point of cross multiplying. Fractions are ugly. We don't want to work with them. When you cross multiply, you should not have fractions anymore. So all we got to do is divide by 6. 112 divided by 6. Our answer is going to become a fraction or a decimal. I'll go ahead and write it as a decimal. We'll round this off to 18.7. And that's how these work. Again, we just use the fact that corresponding pieces go together in the same fraction. They have to correspond some way. 14 corresponds with 6 because they're on the same side. However, 14 also corresponds with x because they're both on top. So I could have, once again, also used 14 and x in a fraction together. It gets confusing, but I just want you guys to understand that there's lots of different ways to do this. Let's go ahead and try it again. Okay, so once more, we're going to write 2 fractions, but take a moment, label your picture. This one is going to be a hair different. So label your picture first. You might get a little confused, though. Okay, let's see what we got. So we've got VW is 12. So from V to W, we have 12. WI is 5. From W to I is 5. And then we have from V all the way down to Z. So all of this is 20. And then our X is going to be this piece right here. We want to find Vx. Now here's the thing. When we are given an entire side, entire sides correspond to entire sides. If I'm given all of this is 20, what I need to realize is this is going to correspond to the entire other side. We're going to have to keep that in mind when we do our fractions. So to start with, if this is 12 and this is 5, what is this whole side? 17. So let's go from here and try and write our fractions. Now, a good strategy is also to start with x, with what you're trying to find first, and build your fractions based off of that for these more complicated ones. So I'm going to start with what I'm trying to find, x. Now, in my fraction, once again, I have options. I need something that corresponds to x. Either it's on the same side as x, or it's in the same position, but on the other side. I'm going to go ahead and choose to use 20. I don't know what this is. Yeah, so I can't use that piece. I do know the whole side is 20, and that corresponds to x because it's on the same side, right? X is here, and then on the same side, that entire side is 20. So what we need, if I went x over 20, my second fraction has to do the same thing. It has to be the number that corresponds to x on the other side over the number that corresponds to 20. Go ahead and try it. Okay, so if I went x to 20, I need to do the same thing for my other fraction. 12 corresponds to x, and 17 corresponds to 20. I hope it's starting to click how we have to do these proportions. Our fractions have to be written in the same way, and this is what I mean by the same way. Top to bottom, top to bottom. Go ahead and cross multiply and solve. Okay, so cross multiplying, we get 17x equals 20 times 12. So 20 times 12, we should get 240. And divide that 17 away. We get x equals 240 divided by 17. Whoops. Again, we're going to be getting a lot of decimals here. This comes out to be 14.1. And again, that is Vx, I guess I should say, but we already called x Vx, so that's fine. We have one last example here. Same thing as always, I want you to try this entirely all the way through. Your two fractions have to be written in the same way with corresponding parts. Label your picture, write your proportion, cross multiply, solve, you can do it. Go ahead and try it. Okay, so Jn is 10. Guys, I see some of you, because I saw some of you in my class, not writing anything down whatsoever. We are not going to be able to do that here. You have to copy the picture and label. If you do not, you're not going to get these right. Be very careful, make sure you labeled this correctly. J to L is 6, and we want KL. There's our X. So if you were not able, or if you labeled it incorrectly and did the whole problem, pause the video and go from here now, trying to get your new proportions. Okay, but I'm going to keep going. So, like I said, a good strategy is always to start with your X over something that corresponds to X. I have two options. I can use either the 4, which corresponds to X because they're in the same position on different sides, or I can use the 6. I'm going to go ahead and use the 6. If you did X over 4, though, you were correct. X and 6 correspond because they are on the same side. So I just went, this is always a helpful strategy, X to 6. My other fraction has to go the same thing. Notice, we are given that the whole side is 6. I need the other whole side. So write your second fraction if you haven't already done so. Okay, so 4 is going to have to go first. Notice they correspond in the same way. 4 and X needs to go to the entire side. What's this entire side here? 10 plus 4, 14, right? 10 plus 4 gives us 14. So from here, we can cross multiply and solve. You can pause the video if you want to try it real quick. I'm going to go ahead and finish it up. 14 times X is just 14X. 6 times 4 is 24. Once again, notice that I do not have fractions anymore. We're going to divide by 14 and once again get a decimal. 24 over 14. We got 1.7. Okay, so we're going to do a couple more practice problems together before you guys do the assignment, because I really want to make sure you understand how this works. Most importantly, how we know what goes together and what can go together in a fraction. That's the most important part to understand about this.